My name is Tony. I'm CEO and founder of Advanced Modular Instruments. Finished up my PhD in chemistry, and so I'm going to be the first one in my family to graduate with a bachelor's degree in higher education also. So that's pretty exciting. When I first started my PhD, I walked around and I talked to a lot of graduate students about their time there, and I wanted to know whether or not they liked it there, how classes were, and most importantly, what I wanted to know was how long did it take for them to finish, because I didn't want to stay there forever. To my core, a lot of them replied that they were graduating in like 7 years, which is crazy. You guys probably don't know this, but for graduate work, they boot you out after 8 years. And when I came back, I asked them why it took them so long. The reply was that scientific discovery is very inefficient. And every year, people waste hundreds of billions of dollars because of inefficient strategies towards supply, labor, and time. There's like different sectors are affected, such as like drug discovery. It takes 15 years to produce one drug. That's ridiculous. Oil discovery takes a long time because you have to identify viable locations. Commercial and industrial biotech, that's very lengthy production time, and academic and clinical research is very time consuming and not cost effective. So why is it that scientific discovery is inefficient? Well, I asked them, and they replied that existing scientific equipment, instruments, are dumb. They're difficult to use, they're unreliable, and worse, you have to babysit the instrument, so you can't just walk off and do your own thing. You have to actually actively monitor it. And that produces a huge time delay for scientific advancement. So I developed Advanced Modular Instruments. We create smart digital scientific instruments that reduce waste, time, and labor by letting you actively monitor your progress. And so we hope to increase workflow and productivity. Hello? Workflow and productivity from it. So to start, I'm just gonna freeze out. Okay, it's all right. It's all right. Oh, I have to use it? Okay. So to start, what we did was we followed around a scientist for a day to see what they do. And we found out that throughout the day they use 3 different types of instruments. The centrifuge, which is a separation instrument that uses centrifugal force. Gel electrophoresis, that is another separation instrument that uses electricity in the silica gel. And then analytics to analyze raw data into meaningful results. So from that, we developed 3 different tools. Our first one is the Smart Tube, which gets integrated into any commercial centrifuge. The second one is a Smart Gel, which gets retrofitted into any commercial gel electrophoresis. And our last one is our analytics package, which is a cloud-based computing package. So when we looked at the market, it's a massive market. The centrifuge market's like $3 billion. The gel electrophoresis market, another $3 billion. Analytics, $3 billion. So we have a massive $9 billion market opportunity. So we went back to the scientists. We asked them what they were doing to relieve the stress. And to our surprise, believe it or not, it's all trial and error. And we actually didn't believe them at first, so we dug deep into Google and like our patent lawyers, and we actually found that it was true. So this is a scientific journal that was released recently this year. This is the procedure section, and it shows, basically it says you have to just repeat it until you get your satisfied results. And our face dropped. We were like, wow, we need to do something about this. So we took our smart devices, we packaged it into a really nice IoT platform, filed 5 utility patents, and we conducted over 120 customer interviews. And from that is our first product, the Smart Tube. This right here is the current solution. You just place your test tube into it, and then you just centrifuge it. Our solution is a smart device that has sensors on there, computer system, wireless communication, and it's able to transmit the data wirelessly to the end user. It's really easy to use. Just place your sample into the smart tube, place that into any commercial centrifuge, and it'll transfer the data wirelessly to a remote device such as your smartphone or your computer. So we calculated that within 3 weeks of purchase from buying this smart tube, that you can actually recoup your costs. And after a year, you'll save roughly $35,000 from saved samples, time, and labor. So the 3 markets that we're going into are pharmaceutical, commercial, and academic. And we chose these 3 sectors because they don't have any regulation. But once we've attained a foothold within these sectors, we're going to go into regulated markets such as oil and clinical. The way that we're going to generate money is through the sales of our smart devices, as well as a recurring annual cost from our a license from our analytical package. The 3 customer segments have multiple entities within it, which we are communicating with. So we have potential entities in the pharma market, such as Regeneron and Novartis, which we plan on reaching out to. In the industry, we've already reached out to Crackler and Thermo Fisher, which we hope to form a relationship with. And within the academic market, we've already established a relationship with Penn and SUNY Albany. We have a great team filled with a variety of talent in chemistry, physics, engineering, and business and law. We have a detailed plan of how we're going to release the Smart Tube in 2017, followed by detailed releases of other smart devices in 2018 and 2019. And since we built our devices on an IoT platform, we can monitor the usage of an average scientist. So what we plan on doing is identifying different instruments that they use throughout the day. And we're going to make smart scientific instruments that will increase productivity. So now, this is the ask portion where we're asking you whether or not you know any software engineers with specialties in iOS, Android, big data, and AWS. And our contact information is at the bottom. So with that, I'd like to conclude my pitch and open up for Q&A. Yes. So the question is, do I have any plans to work with hospitals? Yes. I do have plans to work with hospitals, but that requires regulatory committees which we have to go through. We will do that at a later date once we've established a foothold in the 3 primary sectors.
Are the decision makers in the selling process, or how do you reach them?
The question is, who are the decision makers in the selling process? And that's actually the managers of the labs, and we are actively reaching out to them.
What kind of upkeep does this smart device require to manage?
The question is, how much upkeep does this smart device require? And it does not require any upkeep. It's fairly well contained. It doesn't break down easily, and it should last you roughly 5 years, which is the time frame of the average life cycle of an instrument.
Do you have any security concerns with the static smart wirelessly?
The question is, do I have any security concerns with the data being wirelessly transferred? The question is no, we use encryption with it. We use 128-bit encryption.
You had Thermo Fisher up there. Are you going to have them sell your device, or are you selling directly?
The question is, I had Thermo Fisher up there. Am I going to sell the device, or yeah, I will be selling the device to them.
What platform is your analytics package built on? And will you have integrations? How are you planning on utilizing it?
The question is, what package do I have my analytics device on? And I can't disclose that because that's proprietary information.